This is David, and in this video we're going to look at an example of an application of simple linear regression. Now, this is out of the chapter that's entitled Critical Decision Making. And in that chapter we look at two things. We look at decisions that are based on mathematics, and we look at decisions that are made on human intuition, and we kind of separate the two, which is good because later when we look at the type of market appraisers are in, if they're in a very rural market, they're going to have to rely more on human intuition and less on mathematical. But if you're in an extremely active market, you could probably rely heavily on mathematical techniques to extract adjustment rates. The point, I think, of the chapter Critical Decision Making is that you don't want to rely solely on mathematical. You don't want to solely rely on human intuition. You want to combine them together. And statisticians and scientists now are leaning towards a name for that as augmented intelligence. Now let's look real quick at a data set. And this data set is a hypothetical market. I made it up to demonstrate a specific issue, and I want to tell you about the market. Number one is there is no variance in this. There is no randomness in this because we're actually going to be looking at collinearity, and we're going to be looking at correlation, those kinds of things. Now, this market was built based on the variables of gross living area, bedroom, bath, age, and date. Now, the sales price is based on $100 times the gross living area, $10,000 times the number of bedrooms, $5,000 times the number of bathrooms, and for each effective age take away $3,000. Now, what you'll notice is that the sales price in no way is made up of the date of sale. That's got no effect. So when I look at my formula, I know that the dates are in column D, and there's no D up here. So in this case, date has no effect on sales price. So by definition, that's a stable market. That's your definition of a stable market. It is when the passage of time has no effect on sales prices. So we know the answer, again, because we're doing this as research, we know the answer that it's a stable market. Now, what I'm finding a lot of appraisers are doing, they have this data, but they're going to analyze only the sales price and the sale date. Now, when you have one dependent variable and one independent variable and you analyze that with regression analysis, that's called simple regression. So let's take a look. These are the exact same dates and the exact same sales prices. And when we plot these points and then run a trend in values through it, we see that this is showing an appreciation. Matter of fact, a steep appreciation. But we know that's not right. So we know that this is a situation where our analysis is giving us a bad output. Now, another reason we call this regression is because Excel, when it plots a linear trend line, it uses the sum of the least squares to plot it, which is typically the way regression is done. So when you trend something like this, you may say, I'm trending it, I'm not applying regression. You're actually applying regression if you're doing it in Excel and probably in most of the other spreadsheets. But we got a couple conflicts here. In other words, my first thing is what's going on. So let's go back to our data and let's take a look at a correlation matrix. So what I'm going to do is I'm going to go to data up here, and you can't see it, but I'm going to data analysis, and I'm going to choose correlation. If you don't see these, you need to go and set up your Excel with what's called Excel add-ons. You just need to go up here in File and find that and set them on, turn them on. Okay, so I'm going to say correlation, okay. And let me pull this in so you can see it. Now it's going to ask me where it is, and I just tried it a minute ago to make sure I can run it. But basically that was blank, and I highlight it from sales price all the way down here through age. And then I did say that inside this I do have labels. Remember, in a database, labels. Okay, now I'm going to put output range, and I put output range. Now make sure you click on this first, like you would click here first, and then pick your range, whatever it is. All right, and then say okay. All right, let me pull this over so you can see it better, or can see it, period. All right, now there's the matrix that it made of correlations. And what I'm interested in, the two we're interested in, is date and gross living area, because that's the two we used. And I want to know how well that's correlated, and I can see that it is correlated fairly heavily. Remember, 0 is none, all the way to 1 would be 100%, and you can still go to a -1. But it looks like it is correlated. A 0.67 is a pretty good amount of correlation. Now let's go over with just our eyes and let's look at this. What we're looking at here is the dates are in order. They go from older to newer. The question I have is what happens with the gross living area over time? And I see these first ones are, 1613 and 1614. Then we get up here and they're 16 to 18, some 19. Then we get up here 19 to 2000s. I can see, if I look carefully, I can see that just by chance, the houses as they sold tended to get larger. Okay. Now this doesn't happen every time in a market, but this happens sometimes in a market, that there's just something odd. Now it was pointed out here when we checked our correlation, and remember you could do the correlation another way. You could put equals Corel for correlation, and then pick date, and then pick gross living area, and it gives you the 0.679, gives you the same thing. So you could have done it yourself. So now we know we have an issue that when we use simple regression, the simple regression was not able to work through that correlation and separate those two. Kind of like two trains on one track. They couldn't get them on their own tracks. And when that happens and it distorts the output to where the output is not correct, that's called collinearity. If you have 4 or 5 things that are working against you, or more than 2, that could be multi-collinearity, but we're not going to get into that. So the point of this exercise was that when you do in critical decision making, in the mathematical analysis you use, you need to be sure that you have been trained in it and you have experience in it. And when you do a mathematical analysis, you never just take the output. You always oversee or work hand in hand with human intuition. In other words, you might say, I don't believe that. I don't agree with that. I don't like that answer. And then you might try another type of analysis. Now, what I would suggest really that would be done, by the time that I did this, go back to this table, and saw there was an issue here, by the time I did this, and to run this, I had to have, I had some of these other things too. I pulled them. But if you run a regression analysis, multiple linear, which that is you use all of these, it would give you the correct answer of a stable market, especially because there's no, remember I didn't mix this up with any randomness. Randomness is the #1 thing that messes with your and erodes your mathematical analysis. It's the #1 thing. Probably the second culprit, the next second biggest culprit, is collinearity. And the reason I put variance first is because if you use perfect data sets, regression handles collinearity just fine. So that's the biggest one is going to be the randomness. The second one is collinearity. So we're always going to be looking out on those two. Now let me think if there's anything else I wanted to cover with this. I think that pretty well covers it. So this was just a fun little example of, again, how things can go wrong. And it also shows that there's more to extracting adjustment rates than simply learning a really sweet technique like simple regression and applying it. Now, because simple regression, and I want to mention this again, because we're trying to be research scientists in what we're doing. So let's reiterate something. Because we showed in this one instance that simple regression didn't work, would you totally throw out simple regression analysis? And the answer would be no, because this isn't really enough data to throw it out. In some situations, for some uses, charting like this may be useful and work very well. Now, I believe that for most extraction of adjustment rates, we want to be very careful, and if we're going to bother to do simple, just go ahead, and I would say even though I understand sometimes simple regression will work, I would still suggest that we just move on into multiple linear regression or some type of multiple regression where we do all of the variables or most of the variables. But don't think one little proof, and this is a pretty good proof, this is a pretty good example, and it's meaningful, but it does not destroy or make me believe that when an appraiser uses simple regression, they're always going to be wrong. I'm going to state that because I don't want to be misinterpreted. All right, thank you.